This is worksheet 8.4. We're going to be working with negative exponents, and we're going to make sure that our final answers only contain positive exponents. And so we learned that we can move our powers from the numerator to the denominator or vice versa to change a negative exponent to a positive and then simplify and combine like normal. So number one, no negative exponents. We're just going to go ahead and follow our properties. So we're going to go ahead and multiply here. So our product property says that when we have the same base, we're just going to add the exponents. When we're dealing with the coefficients, those just act like regular numbers. So this is a 1 times a 2. So this is going to be a 2. And then when I go ahead and multiply a to the 4th times a to the 3rd, I add the exponents. And so this is just a to the 7th. So it's 2a to the 7th. Number 2, we do now have negative exponents. So we're still going to go ahead and just follow our normal properties here. There's no reason to try and start moving this right now because we are going to have to multiply it with another x. So before we worry about the fact that it's negative, we're going to go ahead and combine those exponents. And then at the very end, if we still are dealing with a negative, then we'll do something with it to make it positive. But we're not going to start this off by trying to address that. First of all, with our coefficients, again, those act like normal. So we're just multiplying 4 times negative 2. So that's negative 8. And now we're multiplying an x to the first times an x to the negative 1. So the base is similar. It's the same. So we're going to follow our product property, and we're going to go ahead and add our exponents. So a 1 plus a negative 1 is 0. So technically this is x to the 0. But we would never leave that. We know anything to the 0 is just 1. And so it basically just goes away. This is negative 8 times 1. And so our final fully simplified answer is just negative 8. Number 3, multiply your coefficients. That's a negative 4 times a negative 1. So that's a positive 4. Multiply n to the 3rd and n to the 4th. You're just adding your exponents. That's n to the 7th. Number 4, multiplying coefficients. That's a 1 times a 4. It's just 4. Multiplying these. Okay, we're not going to try and deal with this negative right now because first thing we're going to do is we're going to combine these. So when I multiply r to the 4th and r to the negative 1st, I am still just adding my exponents. So 4 plus negative 1 is 3. I don't have to do anything fancy with the negatives. So again, go ahead and multiply and simplify as much as you can. And if you're left with a negative exponent at the end, then we'll talk about how we deal with that. All right, number 5 now, raising this to a power. So what's important is that we make sure both of these receive the power of 2, kind of like distributing. So this is going to be 4 to the power of 2. And then I'm also going to raise this to the power of 2. Now this property states that when I raise a power to another power, I multiply these together. So this is negative 2 times 2. So my new exponent when I multiply those is negative 4. All right, so for this, I'm still a long way away from having a fully simplified answer. I don't want negative exponents, and I'm not going to leave a whole number with an exponent. I'm going to go ahead and simplify that. So 4 to the 2nd, if I just take care of that, is 16, 4 times 4. If you want, you can put the k to the negative 4 here and then go one more step. I'm going to go ahead and do it right now, though. Because I want this to be a positive, I'm going to go ahead and move it down to the bottom. So instead of putting it next to the 16, I'm going to put it underneath the 16. So it would have been sitting right here, k to the negative 4th. You swing it down, and by switching it from the numerator to the denominator, and again, you can go either direction, you change the negative and the positive of the exponent. So this becomes positive k to the 4th in the denominator. Number 6. All right, raising to the negative 1, raising to the negative 1. Make sure both of them get that. So I'm going to have negative 4, and that whole thing is being raised to the negative 1. And I'm going to have x and a power raised to a power. I'm multiplying, so this is to the negative 2nd. All right, so both of these have negative exponents. Both of them need to go to the denominator to make them positive. So this is going to be a negative 4 raised to the positive 1, which I don't need to write anything to the 1. You can just leave. And this is going to be x to the 2nd. They became positive by moving them down to the denominator. Now my numerator is empty in a way, right? There's nothing left up top, so I can't leave it empty. You need a placeholder, you're going to put the 1 there. And this is a good answer. You'll see on the answer key they put that negative sign in front. So technically you could write this as negative 1 over 4x squared. You could even put this up top. We've talked at length about how this negative can go in 3 locations. It can go up here, it can go in front, it can go down here, and they all mean the same thing. Okay, so no need to worry about differences there. Number 7, straightforward. Power to a power. You're going to go ahead and multiply those together. That is n to the 8th. Number 8, make sure both of these get it. So this is 3 to the 3rd. And then it's also, we got to multiply here, our power rule. This is n to the 9th. No need to move anything to the denominator. We don't have any negatives. But we do need to go ahead and expand 3 to the 3rd. 3 times 3 times 3, that's 27. And n to the 9th is good to go, so we just leave it. All right, take a look at number 9. Looking at our quotient rules now. We have similar bases. We're looking at our powers, which means we're going to go ahead and subtract our exponents. And this is just division when we're looking at our coefficients here. So 4 divided by 4 is 1. They basically just disappear. They cancel each other out. And another way to think about these is you have 4 r's on top and 3 r's on the bottom. And so if you rewrote it, you could have r times r times r times r. And on the bottom, r times r times r like this. And so these would cancel, leaving you 1 on top. So you had 4 on top, you had 3 on the bottom. So when these 3 cancel 3 of them on top, you're left with 1. So this is just r to the first, which is r. And the coefficients, again, cancel it out completely. So that is your final answer. Again, the other way to do it is 4 minus 3. That's the quotient rule. 4 minus 3 is 1, so it's r to the first. So lots of different ways to think about it. Okay, whichever one makes the most sense is what you go with here. So 4 divided by 4, those cancel each other out. R to the third minus r to the first. We're dividing, but we're going to subtract our exponents. That's r to the second. Or you think about that I have 3 r's up here. I have 1 r on the bottom. This 1 r cancels one of these, leaving me 2 on the top. Okay, 11. Coefficients, I can't do anything with those. Okay, 2 and 3, if I divide that, I get a nasty decimal. They are fully simplified, so I'm going to leave it 2 and 3. And I'm just going to deal with this. This is b to the third, b to the first. Quotient rule says subtract. 3 minus 1 is 2, so it's b to the second. If you're going to go ahead and use that subtraction rule, no matter what you get, that is going to end up here in the numerator. So even if you subtracted and you got a negative, you would put it up here in the numerator, and then you'd throw it down to the bottom. If you're going to go ahead and use cancellation, which when we get into the more complicated ones with negatives, I actually like better. If you're going to use cancellation, you just cancel everything, and then wherever everything is, you just leave it. So if you happen to have more left over on the bottom, you would leave it there. If you have more left over on the top like this, then you leave it there. But again, if you're going to go ahead and use the quotient rule and subtract whatever you get, positive or negative, doesn't matter, that goes up top. And if it is negative, then you're going to have to move it down to the bottom to fix it. So more on that here in just a second. So when I get to number 12, first of all, the 2 and the 2 are going to cancel. But when I'm dealing with this, I have m to the first and m to the negative third. I got lots of different ways to think about it. So hopefully one of these makes sense for you. First of all, if I'm going to go ahead and I'm going to use my quotient rule, okay, I'm subtracting. So looking at these numbers, it's 1 minus negative 3. If I'm going to go ahead and subtract my exponent, well, that goes plus plus. And so 1 minus negative 3 is 4. So my final answer is m to the 4th power. For some of you, you look at that and go, great, makes sense, easy, no problem. Okay, another way to think about it is I want to fix this negative. Okay, in order to fix this negative, m to the negative third, I need to bring it up top. It becomes m to the positive third. Once it's up there and it's positive, this is my product rule. I'm combining these, a 1 and a 3, make m to the 4th. Okay, so another way to look at that one. All right, 13. So we're going to look at some more complicated ones now. There's more going on. So what I would want to do here is simplify the numerator and denominator as much as possible before I even start moving things around. So the denominator, there's nothing I can do. Of course, I do want that negative to get out of here. But for now, because I have multiple n's up top, I want to go ahead and combine those and see what's going on up there. So I'm going to leave the n to the negative first here for a second. This isn't the only way to do it. You don't have to do it this way. But I highly suggest if you have multiple bases up here on the numerator, or even if they're in the denominator, and you can simplify them. So like over here, we've got these n's. Put them together first before you start moving stuff. I think that's going to make your life a lot easier. So based on my product rule, multiplying here, I'm adding my exponents. So a -4 and a +4 makes 0 when I add them. So these, when I put them together, give me n to the 0, which basically goes away. So I'm left with just a 4 on top. And this would be done except I have a negative. Okay, and so I can't leave a negative exponent in a simplified answer. I move it up to the top to make it positive. So it becomes positive n to the first up here. There's nothing left in the denominator, so my final answer is just 4n. Another way to think about it, if we want to kind of get a little more into it, if I went ahead and I subtracted these, I had n to the 0, right? So I have n to the 0 on top and n to the -1 on the bottom. I know based on my quotient rule I'm subtracting. So this is 0 minus -1, 0 minus -1, which goes plus plus. And so 0 plus 1 gives me n to the first. And there it is in my answer. So there are multiple ways to think about this. Hopefully one of them clicks and you just follow with that all the way across. All right, 14. I see multiple n's here in the denominator, so I'm going to go ahead and simplify this completely on the bottom and leave the top for now. So 3n squared, leave that alone, deal with it later. Let's go ahead and simplify here. So this is multiplication, which means coefficients, you just multiply, that's 8. And that means when I'm dealing with my similar bases, I am just adding these. So -2 plus 4 is just going to be n to the second. -2 plus 4 is 2. Now, I've got n to the second over n to the second. Quotient power says 2 minus 2, that's 0. Or basically, I have n times n to the second on both, and they're all going to cancel each other out. Anything over itself is going to cancel. So final answer here is just 3/8. All of the n's cancel out. Okay, 15. Multiplying across here, leave this for later. So I'm going to leave 3n to the -4th for later. And I'm going to multiply here. Now, I do want to come back here for a second. If you saw these 3's, you actually could cancel them here. So that is an option. But I'm going to go ahead and multiply here. So I'm going to get 6 with my coefficient. And dealing with my powers, I'm adding. So this is n to the 4th. And 6 divided by 3, and my final answer is going to give me 2. Now, if we had canceled these 3's early, there's your 2 still sitting there. Okay, so definitely that's not a bad way to do it. And I do need to get rid of this negative. Now, people want to cancel this. They want to say, oh, there's a +4 and a -4, so they cancel. No, they would cancel if you had the same thing on the top and the bottom. N to the 4th over n to the 4th. That would cancel. This does not. So I want to fix the negative exponent by bringing it up top where it becomes a positive exponent. So now I have an n to the 4th and an n to the 4th, and these are being multiplied. And so that becomes n to the 8th. Nothing left on the bottom. That's my final answer. Okay, 16. Just taking a quick look at it, you kind of want to plan your strategy ahead of time. I'm going to go ahead and simplify the bottom. That's v to the 5th. Now, here's one where if you think about it as in cancellation, so 1, 2, 3, 4, and 5. Up here we have 1, 2, 3, 4. 4 v's will cancel. But where is the leftover v? It's in the denominator. That's where we started with more. Okay, so in my final answer, I already know that there's going to be 1 v left over after all of these cancel out, and it's going to be in the bottom. This 4 is just going to remain up top, and this is my final answer. But for some of you, the cancellation is not the way you want to do it. Now, this, again, is where some people are going to want to cancel everything and say, oh, I got 1 left over. How come it doesn't go in the top? And again, it's because you had 5 on the bottom and 4 on the top. So you cancel these 4 on the top with 4 on the bottom. Where is your leftover v? It's not on the top, it's on the bottom. Leave it there. Okay, if these were switched and you started with 5 up top and 4 on the bottom, then your leftover would be on the top. Now, if you're somebody who likes to use the quotient rule, where you just see that you're dividing similar powers, so you go ahead and you subtract, you're going to do 4 minus 5, and that's negative 1. So you're going to end up with 4 times v to the negative 1. If you go ahead and you use the quotient rule, always put that up top, okay, even if it's negative. And then you fix it, so it's to the negative first. I'm going to go ahead and bring it down, and it ends up right down here, and you end up with the same final answer. Okay, so if you're canceling, whatever's left over, leave it where it is, either on the bottom or on the top, wherever you started with more. If you're going to use the quotient rule and subtract, okay, always put it up top, even if it's negative, and then fix it. Now, as you get better with that, you might just automatically subtract and get a negative and go, oh, I put negatives in the bottom, kind of skipping that middle step. But when you do put it in the bottom, make sure that it's now positive. Okay, it should be a negative up top. You move it to the bottom to make it positive. Okay, so I just threw a bunch at you there, but hopefully one of those makes sense. You don't have to understand all of them. If the cancellation works for you, then go with it. If the quotient rule works for you, you just like to subtract the exponents and fix it later, then go with that. Okay, you have to find what works best for you. 17. All right, looking at the 4 and the 3, nothing's going to work out with those. They're just going to stay. There's nothing to simplify. And I don't have anything to combine on the top or combine on the bottom because I have an x and a y. Those aren't going to go together. I have an x and a y. Those are not going to go together. So now we have multiple bases, multiple variables here. They have to stay separate. So treat each one individually. Since I have my x's both positive here, let's just start with those. Okay, quotient rule says I'm subtracting. So 4 minus 3 is 1. When you use the quotient rule, your answer always goes up top, at least to start. But since it's a positive 1, 4 minus 3, positive 1, it's going to go up top and it's going to stay up top. It doesn't have to go to the bottom because I didn't create a negative. The other way, again, to think about this is you have 4 x's up top, 3 on the bottom, and you don't have to draw these out every time. And these 3 would cancel these 3, leaving you 1 on top. I like that rule better myself, and I don't normally write this out. I just look at it and say, oh, there's 4 on top, there's 3 on the bottom, so cancel as much as I can. These 3 cancel 3 of these, meaning there's 1 left over on top, and I just throw it right there. Okay, now a couple ways to approach your negative exponents here. You can use your quotient rule, and so it's negative 3 minus negative 4. You gotta have to be careful with all these negatives and subtraction signs. Negative 3 minus negative 4. Well, what does that do? That goes plus plus. Negative 3 plus 4 is 1, and so my exponent is a positive 1. No matter what, whether it was positive or negative, when I use the quotient rule, it goes up top, and then fix it later. But there's nothing to fix here because I did get a positive 1. It goes up top, and it just stays there. And this is your final answer. Now, there's lots of different ways to approach this. Here's another way. If you look at these, they're both negative. So really, we want to fix them, right? So what you could do is you could take this one and bring it down, and it becomes y to the positive 3. And you could take this one and bring it up, and it becomes y to the positive 4. Now you have 2 positives, and you can cancel it just like you did with your x's, and you can see it's the same. 4 and 3, 4 and 3. So you do 4 minus 3, it's 1, boom. You can get rid of your negatives altogether. So if you know you have the tendency of really just messing up when you have negatives and you're trying to subtract negatives, then don't even bother. Bring it up, bring it down, create all positive numbers, and then you just deal with it like normal. These 3 cancels 3 of these, 1 left over, or you do 4 minus 3 is 1. All right. 18, coefficients. Nothing going on. We're going to end up with a 2 up here in our numerator. Looking at my a's, there's no negatives, so just treat them like normal. I have 1 on the bottom and 2 on the top. So this 1 will cancel 1 of these, meaning there's still 1 left over up top. So there's my a. Or you could have thought about it. Use your quotient rule. 2 minus 1 is 1. Goes right there. And dealing with this, if you want to use your quotient rule, it's 4 minus negative 2, which goes plus plus. And so that's 6. So it's b to the 6th power. Nothing left over on the bottom. That would be a 1, which you don't even need. So you can write this as 2ab to the 6th. Side note, as you start writing these out and you have multiple variables here, you do want to put them in alphabetical order. You'll notice on the answer keys that's not always true. Okay, so it's not completely crucial. Depending on which textbook or which program you're working out of them, some of them really emphasize that and some of them don't. I prefer to see them in alphabetical order. If the B was in front, it just looks weird to me to have the A after it, just because I'm used to that alphabetical order. But it's not going to be marked incorrect. So just know it's not that big a deal, but try and put it in alphabetical order. All right, going back to this here for a second, if you don't like doing the subtraction with the negatives, you know you mess up negatives, then let's get rid of this negative by bringing it to the top and making it positive. And once you've got it positive up here, you're just combining these, and now it's just 6. Okay, so I kind of like that. I'm one who can get confused with negatives sometimes when there's too much going on. So go ahead and move it, make it positive, and then deal with it. All right, we get to 19 and just kind of random. It's an easy one. 2 and 2 cancel each other. 4 minus 2, because this is quotient, this is division, so 4 minus 2 leaves you just positive 2. Done. Or think about you have 4 on top, 2 on the bottom, so these 2 cancel 2, and there's still 2 more left on top. All right, and we're to number 20. Coefficients, 4 and 3, nothing going on there. You cannot simplify that anymore. The only m in this problem is up top, and it's positive. It's negative. I want to make it positive, so I'm going to bring it down to the bottom. It's going to become positive m to the first. And since there's nothing else to combine it with in terms of m's, I know that's just going to be in my final answer in the denominator to the first power, which you don't have to write first power, so I'm just going to leave it m. And for me, this is the way I like to do it. I like to just move this, make it positive down here, and now just combine it. Okay, n to the second, n to the first, that is n to the third, and I'm done. But you could use the quotient rule. So for those of you that like that, I'm subtracting. So it's negative 1 minus positive 2. Negative 1 minus 2 is negative 3. And so what this creates is an n to the negative third. When you use the quotient rule, it goes up top. Because it's n to the negative third, though, I do have to shift it down to the bottom to make it positive. And then I would still end up with my same final answer. Okay, so there's lots of flexibility in this in terms of strategies. Find what works for you, moving your negative exponents or just following the property and subtracting using negatives and then fixing them later. That's fine too. Whatever's going to work. I just say that you should probably be consistent until you fully understand all the different strategies, and then sometimes one may be better than another. The more tools you have in your toolbox, the better. So if you can understand how to solve it different ways, you can pick and choose when to do it. Otherwise, though, find the one that works best for you for now and just stick with that one. If the other ones are just confusing you, but one totally makes sense and you get it right every time, then there's nothing wrong with sticking with that one.